Alright guys, on number 1, I am giving you basically 2 points. And if you know 2 points on a line, the calculator can tell you the answer, at least in slope-intercept form, right? So giving you intercepts is just as good as giving you points, but you had to know what points that was. If the x-intercept is -8, what point is that? -8, comma, 0. And if the y-intercept is 6, then that's the point 0, comma, 6. So you did have to know where to put the 0. And then you just get the calculator to tell you the slope-intercept version, right? So I got y equals 0.75x plus 6. Now normally they're probably going to have fractions, not decimals. So that's y equals 3/4 x plus 6. You have to be very good at converting from one form to another. How could I get this in standard form? Multiply everything by 4. That's going to be 4y equals 3x plus 24. Subtract 3x so it can move over to this side. -3x plus 4y equals 24. I want x to be positive, so everything changes signs. 3x minus 4y equals -24. So that's one version, and here was the other version. You got to be able to do both. Are we okay with that? Trajan, are you okay with that? All right, number 2. I am giving you a point and a slope, but in kind of a tricky way. I didn't tell you exactly what slope to use, but I told you to be perpendicular to this line. That means I don't care what this line's y-intercept is, but I need to look at its slope. What slope should I use to be perpendicular to it? 1/4. You got to flip it and change the sign. Now, if I had wanted to be parallel to it, I would have used -4. Parallel lines have the same slope, but I wanted to be perpendicular. So you had to flip it upside down, and you have to change the sign. Negative becomes positive. Now, that's just phase 1. Now I have to find my y-intercept still. I gave you a point, and you had to figure out the slope I wanted you to use. Y equals m times x, or x times m. Y equals m times x plus b. Now something nice happened here. -12 over 1 times 1/4 becomes -3. So the fraction disappeared on its own. What was the b value? 11. So here's my first version. Y equals 1/4 x plus 11. If I were you, I would stop right there and at least make sure the point that I gave you is on that line. Which I didn't check the last one, I should have. But y equals 1/4 x plus 11. Look at my t-chart. The information I gave you was that -12, +8 should be on the line. And it is. The other thing that had to be correct is you had to use the right slope. So you just have to know that part. Now, that's my slope-intercept form. What if I required, and I did, standard form? Multiply everything by 4. That would give you 4y equals 1x plus 44. Move that 1x to the other side, it becomes -1x plus 4y equals 44. Force it to be positive. And there you go. Are we good with those? Alright, number 3. I am giving you a point and a slope, but again in kind of a tricky way. Right, JJ? This is the one you were asking about. So what point am I supposed to use to do number 3? -4, 2. And I gave you a slope in a tricky way. I told you to be perpendicular to this line right here. Well, that means I've got to know what this line's slope is. What is this line's slope? This line has a slope of 1/2. So what slope should I use? -2. So then I would go y equals m times x plus b. 2 equals -8 positive 8 plus b. So what does b equal? Not 6. -6. Alright, so y equals -2x minus 6. Now let me show you, we still haven't converted it yet. It really doesn't take that much to convert this one though. Move the 2x over and it becomes 2x plus y equals -6. That one was easy to convert. Let me show you how you could have also used the picture. I know you didn't have the picture in front of you because it was up here on the screen. Sometimes you get lucky and the picture can help you find the answer. You had to know that this slope was positive 1/2, and you had to know that that means your slope is negative 2. So I'm going to put my pencil or my pen on this point, and I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And I got really lucky. I crossed the y-axis at a nice whole number, and what was it? Negative 6. Right here, negative 6. Sometimes the picture will actually help you find the answer. That only worked, though, because it was a nice whole number. Trey, you're dying for me to call you out again, aren't you? All right. Finding intercepts, folks. You can find intercepts always by just putting a 0 in for whatever the other variable is. Like if I want the y-intercept, I put a 0 in for x. 1/3 times 0 is a giant 0. What's the y-intercept? Negative 12. It was also super easy to know the y-intercept here because it was in slope-intercept form. So there it was right there. To find the x-intercept on any kind of function, all you've got to do is put a 0 in for y. You also could have found it by doing y equals in your calculator and also doing y equals 0 and seeing where they intersect. It's like finding the 0. It's like finding the root, finding the x-intercept. You also could do it mathematically. I put a 0 in for y. I could get rid of the fraction now. I could move something to the other side now. It's up to you. If I add 12 to both sides, I would have 12 equals 1/3 x. How can I get rid of that fraction? Multiply everything by 3 and you get 36 equals x. The x-intercept here was a 36. Slow clap from Ariana. Thank you. All right. Any questions on any of that? The review that we did on Friday. Let me talk to you about that review on Friday. I am not going to pick it up right now because I want you, especially you UIL people who are going to be gone, I want you to have access to it to study it. What I would do probably is take it out, redo or look at again a couple of problems a day. Here are all the answers. I gave them to you Friday. And you were supposed to finish working it out. But I am going to pick this up, but I want you to have it at your disposal until Friday, the day of the test. So was there anything that you were supposed to finish it, or maybe you had a question on it and we didn't have a chance to talk about it? I think number 16 to me was probably the trickiest one. Was that the one where you had to do a lot of work? Yeah. On number 20, when I put it in standard form, let's look at number 20. What happens when I put it in standard form? So you're okay with this, right? Okay, because it was definitely shaded under. I could tell the slope was a positive 1 and the y-intercept was a 5. Now, standard form, x's and y's are on the same side, right, Camilla? So I'm going to move that x to the other side. It's going to become negative x plus y is less than or equal to 5. They might have that version down there, and we'd be done. But lots of times they force x to become positive. Think about how you do that. Yeah, you multiply everything, or you can think of it as dividing. We're either multiplying or dividing by negative 1. It accomplishes the same thing. But anytime you multiply or divide an inequality by something negative, the symbol flips. So yeah, that was a little tricky thing about number 20. You graded it. Oh, created it? Me. I made it. You don't like it? No, I like it. Okay, any other questions about the review? Keep it. I would do a couple a night. There's probably going to be 20 to 25 questions on the test. But I would give you the whole entire period to do it. We'll see. Bonuses will depend on everybody's behavior, including Coolio back there. No. Coolio. Y'all don't know who Coolio is? He used to wear his hair like that. Oh, well, he was a rapper back in my day. Okay, let's talk about today's lesson. We are moving on to something new, and this is not this is not going to be on the test. Because it's going to be on the next test, and we're already behind. I don't think so. Systems of equations. Remember that word problem on the mock test about the keychains and the coffee mugs? That's a system of equations. Now, systems of equations take several lessons because there's so many different ways to solve a system of equations. First, let's talk about what a system of equations is. And we're just looking at linear right now, but you could have a system of all kinds of different equations. We're going to look at a system of linear equations. That's when you've got more than one equation happening at the same time. In this case, we're going to look at more than one line happening at the same time. And we're trying to solve their system. Today we're just going to look at 2 equations at a time, but you could even do more than 2 at a time. And we're trying to figure out the solution to the system of that equation. Okay, now think about a line and think about 2 lines at a time. What do you think the solution to their system of equations would be? Where they intersect, absolutely. Okay, so with the system of equations, there are 3 different possibilities. Sometimes you're going to have 2 lines that intersect. And that's the case we're going to look at most of the time. We're looking at the 2 lines that intersect, and you're looking for the one point where they cross or intersect each other. So a solution to a system of equations is a point. It's not a number. It's a point. And a point has an x and a y. And if 2 lines are going to intersect, they can only intersect once. So you're looking for the one point where the lines intersect. That's not the only possibility that you could come across, though. Do all lines intersect? Parallel lines do not. So if you happen to come across a system of equations involving parallel lines and you're asked to find the solution, the answer is there is no solution because they will never intersect. And there is one more possibility. Okay, and this is when the lines are collinear, or where they coincide. What do you think that means? It means they're the exact same line. And the thing is, it's not always very obvious, because think of all the different ways we can write the equation of a line. You might not realize you're looking at 2 lines that are the exact same line, but when you go to graph them, they're going to line up one right on top of another. So yes, so what would the solution be when they're the exact same line? Now, that's what a lot of kids want to say, all real numbers. But the thing is, the solution to a system is not numbers, it's a point. Well, you would just say that there are, all real points, infinite solutions. So you're either going to have no solution, infinite solutions, that means all the points on the lines the 2 lines are the same, that's if they're the same line, or you'll have one point as the solution, and that's the case that we're going to look at the most. One year they did put one of these guys on there, though, and I hadn't really stressed this, so just beware. Sometimes they might actually be the same line, and that means they intersect everywhere. Parallel lines, no solution. Now, if you're looking for the one point where they intersect, what's one way you think you could solve a system of equations? Putting it into y equals and seeing where they intersect. That is absolutely a great way to solve a system of equations. There's lots of different ways to solve systems. Graphing is absolutely one of them. That's not what we're going to look at today, though. I want to get to the one that we're going to use the most. Graphing is a great way to do it if they are ready to be graphed, if they're already in y equals form. And if they're not, you're going to have to make them be in y equals form. We're going to look at a different method today to solving a systems of equations, and there's a ton of different methods. Today we're looking at what's called the elimination method. We're going to force one of the letters to go away. We're going to eliminate it. Sometimes this is referred to as the addition method. Yes. It's just adding the two equations together. Now, the first ones I'm going to give you are going to be kind of rigged for you. They're kind of already set up to work really nicely with this method. Let's just start with a super easy one, okay? Now, the elimination method, this normally is when your lines are in standard form. Are these the same line? No, I can tell they're not the same line. They're both in the same form and they don't look alike. So, are they parallel? I don't think so. They're not. I can't really tell because they're not in slope-intercept form. But I'm just going to tell you they're not parallel. So guess what? They are going to intersect at a point. We're trying to find the one point that's on this line and this line. There's one point that works on both. Now, this one is already kind of set up for you to where something nice is going to happen. It's already ready for something to get eliminated. Not the X's and the Y's. No. The Y and the Y. Because this is a positive Y and this is a negative Y. So we're going to add these two equations together and the Y's are going to get eliminated. It's 2x. There are no Y's because the negative Y and a positive Y cancel out. 2x equals 18. What does x equal? 9. Am I done? That's not a point. That's part of a point. That's the x value of the point. We still need the y value. So I am halfway done. I know that the x value where these two lines cross is a 9. Now I got to find the y value. There's lots of things you could do. You could go back and force the x's to cancel each other out. You'd have to do a little bit of work first. Or, this is what most kids do, we're going to substitute an x value of 9 back into either one of the equations. We just found that x equals 9. So in this equation right here, what can I replace x with? 9. If 9 plus y equals 6, then what does y equal? Negative 3. Subtract 9 from both sides and you get y equals negative 3. All I did was put an x value of 9 because I just figured out x had to be 9, and then I solved this equation by just moving that 9 over. I also could have put it in here. Put a 9 in here. 9 minus y equals 12. Now this one's a little trickier because there's a negative sign in front of y. Subtract 9 from both sides and what do you get? Well, you get negative y equals 3, and then what would y equal? So you're still going to get the same y value. Doesn't matter which line you put it into. That's the one point where those two lines do what? Intersect. To check it, I could graph both of these. I could put them both in graph form and see if they intersect at positive 9, negative 3. Here's another thing you could do. My original problem was x plus y equals, x plus y equals 6, and then I also had x minus y equals 12. And we just said that the answer was positive 9, negative 3. I'm going to put a 9 in here and a negative 3 in here. Is that a true statement? Does 9 plus negative 3 equal 6? Now I'm going to check this one. Is 9 minus negative 3 equal to 12? Yes, you see how it works on both lines? That's the only point that's going to work on both of those lines. And we just solved it by adding them together. Something canceled out. Alright, number 2, let's look at this one. Negative 3x plus y equals negative 3. Positive 3x plus y equals 9. This time the x's are set up to cancel. Do you see why? Because one has a negative 3 in front of it, one has a positive 3 in front of it, and when you add negative 3x to positive 3x, you just get a giant 0. So I'm going to add these two things up. My x's will cancel out. And what do I have? 2y equals 6. So y equals 3. Am I done? No, I have found half of my answer. This time I found the y value first, not the x value. How do I find the x value? I plug in a 3 for y into either of the two equations up here. Which one do you want to plug it into? Yeah, the bottom one looks nicer because it doesn't have a bunch of negatives. I'm going to put a 3 in for y because that's what my y value has to be. So I'm going to have 3x plus 3 equals 9. 3x equals 6. What does x equal? 2. So there, I want you to write your answer as a point. My point where they intersect is 2, 3. I'm going to put a y equals 3 into this one just to show you I'm going to get the same answer either way. 3x plus 3 equals negative 3. I'm just trying the other equation. I put in my y value in for this y. That would give me negative 3x equals negative 6 when I subtract 3. And negative 6 divided by negative 3, also positive 2. So it doesn't matter which equation you do the second part with. Alright, you try this one. Number 3. Negative 7x plus y equals 1. 7x plus 3y equals 3. Is this ready to go for the elimination method? It looks like it is to me. For the elimination method to work, you need a... No, the other one can't be the same. Well, actually, you don't want them to be the same. You want them to be exact opposites. You want a pair of coefficients that are the exact opposites. Because when you add negative 7x to positive 7x, that's going to eliminate the x's. You only want to eliminate one. But the y's won't get eliminated. We'll be able to find the y value by eliminating the x's. And how do I eliminate it? Just by adding these two things together. Because I can see that negative 7x and positive 7x is just going to cancel. It's not a decimal. What did you get when you added these two equations? Yeah, if I add these equations, the x's cancel. 1y plus 3y is positive 4y. 1 plus 3 is 4. What is y? 1. Am I done? No, I only have half of my point. I'm still looking for the x. Pick an equation. It doesn't matter. Pick this one or this one. Put a y value of 1 into the problem. I'm going to do the bottom. So that would be 7x plus 3 times 1, because that's my y value, equals 3. 7x plus 3 equals 3. Now, this number freaks y'all out sometimes. Subtract 3 and you get 0. What's 0 divided by anything? 0. So my point where they intersect is at 0, 1. At the y-intercept. Very good. Kenny, look at you. The curse is lifting. Okay, shall we kick it up a notch? Let's do one that's got a fraction before we kick it up a notch. We'll kick it up half a notch. 5x minus 3y equals 14. 8x plus 3y equals 12. Is this one set up for elimination? No. Yes. How do I know? The y's are set up to cancel, to be eliminated. If I add them up, a negative 3y and a positive 3y will cancel out. So yeah, this is ready. This is good to go for the elimination method. Now, the ones we did so far had nice whole number answers. Everything was wonderful. Yes, the good times are over. Well, one of them is. Alright, for my x's, I'm getting 13x equals 26. So at least the x value was a nice whole number, right? So I have half of my answer. Now, pick an equation and put a 2 in for x. The bottom looks nicer to you guys? If I put a 2 into the bottom equation, I'm going to have 8 times 2 plus 3y equals 12. That's 16 plus 3y equals 12. That's 3y equals negative 4, right? And then divide by 3, I'm getting negative 4 thirds. Is that not what y'all got? So these two lines intersect at positive 2, comma, negative 4 thirds. Are we done? So cute. No. We are not there yet. Number 5. No, we're just going to do elimination, but all of those were your training wheels. We're about to take the training wheels off. Because we forced one. It's called elimination because we eliminated one of the elimination. We're eliminating one of the letters. You thought it was like lighting something up? Illumination? Okay, now look at this one. Do you see how the training wheels are off here, folks? Why? What's going to happen if I add these together? Nothing. Nothing gets eliminated or illuminated, right? Oh no, there's a solution. Are you just making up things? Okay, does somebody in first period figured it out? Anybody have a clue what we could do? We're going to have to rig it for ourselves. Camilla? If you double what? If you double the bottom equation, is it okay to double a whole equation? Absolutely. What is that going to accomplish if I double the bottom equation? Then my x's will be eliminated. Sometimes you've got to rig it for yourself. So if you look at this x had a 2 in front of it, and if only this x down here had a negative 2 in front of it, then the x's would cancel. Well, no problem. Let's force it to have a negative 2 in front of it. Now, you can only do that if you double everything. So that would be negative 2x plus 8y equals 14. And then you would have 2x plus 7y equals 16. I'm just going to rewrite the top equation. I like to have them right next to each other. And now the x's will cancel. And you get 15y equals 30, and y would equal 2. Now, go back to either one of the original equations or even the new equation that we created by doubling the second one. You said 0.50. You weren't even close at all. You didn't even have one of the numbers close. Lily, you were wrong. Just get over it. Lily was wrong, folks. She was just trying to guess random numbers. Okay, so I'm going to put a 2 into the original top equation for y. I'm going to put a 2 in for y. So I would have 2x plus 14 equals 16. That would be 2x equals 2 and x equals 1. Now, how would I write the answer? 1, comma 2. I want you to write your answer as a point with the x number first and the y number second. That's the one point where these two lines intersect. I'll show you. Let's practice the skill first, and then we'll do the word problems. All right, number 6. I'm still not done with you. Alright, I need y'all to look up here and put your thinking caps on. Let's see if anything is illuminated out there. Alright, guys, come back, come back, come back. Focus here. You could do that. You could do that. I see Sariana's light bulb came on. Anybody else? Okay, here is the deal. Here's the deal, folks. This one doesn't have an easy fix like the last one, where we notice, hey, all we got to do is double one of the equations, and the x is canceled. So on ones like this, it's kind of like, folks, it's kind of like finding a common denominator. You need to make a choice. Do you want to force the x's to cancel or the y's to cancel? I'm going to do it with the x's, and then I'll do it with the y's too. But usually you look to see if you've got, either one is equally difficult here, because you want to see if your x's or your y's have opposite signs, and neither one of them do. Do you see how both my x's are positive and both my y's are negative? First thing you got to think of, you need opposite signs. So I'm going to look at my x's. What can a 5 and a 3 both turn into? 15. But I need one of them to be a 15 and one of them to be a negative 15. So that means I could multiply the top equation by negative 3 and the bottom equation by positive 5. Or I could do the top equation by 3 and the bottom one by negative 5. But somehow, some way, you've got to force one of your coefficients to be a positive 15 and one to be a negative 15. And then the x's will cancel right out. What could we have turned the y's into? 10. You could have also multiplied the top equation by 5 and the bottom equation by, well, negative 2. You would have to change the signs. You have to have different signs. Everything. You cannot just change part of an equation because you want to. I don't. But I have one of the big pink erasers, but I want it back. It's on my desk. Okay, so somebody tell me the new version of the top equation. Yeah, remember everything, including the other thing on the other side of the equal sign, has to get changed. You can't just change part of an equation. You got to change the whole thing. So I'm getting negative 15x plus 6y equals negative 24. My new bottom equation would be positive 15x minus 25y equals 5. And now when I add them up, the x's will cancel right out. And I'm getting negative, 19y equals negative 19. So what is y? 1. Now, you could go back to any of your other equations, the original two, the two new ones, it doesn't matter, but pick an equation and put a y value of 1 into it somewhere, and then find the x. Y'all do that. I'll wait. Alright, I got 2. So then the final answer is the point 2, 1. Are we okay with that? Alright, your homework is going to be on page 346, 1 through 10. Show your work, write your answer as a point. 346, 1 through 10. They're all rigged for this method. They're all set up to be, they're already in standard form, they're already lined up.